I'm the last guy that's keeping you from lunch, so I will try to keep this brief. This presentation, I wanted to go over sort of a high-level future of Smart Device Link. I want to basically say what we are currently doing, what's in the very near-term future, what we've kind of recently accomplished within the last few months, and then some crystal ball future predictions, I guess, in my mind. So a disclaimer, some of this is just kind of my opinion and my outlook, so don't take it as, the word of SDLC. Before I get started, I want to make an observation that's not necessarily directly involved with Smart Device Link. I don't know how many of you use smartwatches. You want to raise your hands? Anyone? There we go. We got a few. Good. Don't be embarrassed. It's fine. I have one too. And I've been using it since actually, Android 1.0. Now, for those of you who have been using it since then, at first it was really awesome. It was really neat to see those notifications come from your phone and have that control of some of your apps. And then you started to realize that's kind of all it is. It's just a couple notifications and very minor things you can do with your apps. And you suddenly realize the burden of having to charge that device, taking it off your wrist every day and getting it back on didn't really outweigh what it actually did. So a lot of people dropped off at the first version, which is unfortunate because when Android 2.0 came around, it introduced things that basically should have been in Android 1.0, right? It gave a much more integrated experience to the apps on your phone. A lot more content, a lot more things could be done. It even introduced the marketplace on your device. So no longer did you have to get out your phone. And that's the parallels that I draw with Android Wear and Smart Device Link, is we're trying to solve the same problem, but just in a different atmosphere, right? They're trying to make it so you don't have to get out your phone while you're walking, while you're in meetings, and we're trying to do it in the car. And we realize that users want a better experience. They want access to their content regardless of what screen they're using, and they want control of that content too. So it's our responsibility to try to provide that for them. And as we look back sort of at our introduction of App Link and then Smart Device Link, we can see we've sort of went through the same iterative process as Android Wear. We started out with those basic notifications, very basic menu structures that we could accomplish. But unlike Android Wear, when someone bought a car, they weren't just going to dump it off after a few months. So we got to keep our customers a little longer. And then we started creating more compelling experiences. And I think we're now to that point where we aren't just, enabling users to not have to get their phones out. We're actually making them want to not get their phones out. So I see three goals for Smart Device Link to continue into the future on that same path. The first is compelling features for consumers, which goes back to the story I've just kind of told. We have to make sure what we're providing is actually something usable and something that consumers actually want, because sometimes we get wrapped up in the actual technology focus of it, that it's like, this is really neat and it's really cool, but who the hell is going to use it? So we want to make sure that what we're doing is actually for someone, and we need to create those compelling features. The second piece is the friendly and comprehensive APIs for developers. And again, at the library level, we again do very neat things, but we want to make sure those things are very easily accessible for the app developers, because they're the ones that are actually bringing the content to our screens. And thirdly, we actually need those screens for them to provide content for. And that's for automotive companies. They need to have a customizable and secure ecosystem to evolve in. And this goes through our policy server of enabling different features for different apps, as well as OEMs to maintain their branding while this content is being displayed. So as far as near-term features, these are the things that we have coming out within the next couple of months. And we start with System Capability Query. And this starts to get a little technical, so I apologize. When we first started the App Link protocol, the register app interface started to become this very descriptive response that we got from the system. And as we moved to Smart Device Link and we started adding more features and more features, this single message became completely bloated. So recently, we decided to move forward with a new sort of new RPC that you could just query the system to say, hey, do you have that capability? And the best use case I see for this is, for example, video streaming. Now, as Timur already mentioned, we're not going to allow a bunch of different video streaming apps, but for navigation apps, they care what kind of video streaming capabilities are available. So if they send this get system capability request, the core will read its configurations, and it will know, what video streaming protocol it supports, what video streaming codec, bit rate, resolution, and things like that, and it can send that back to the proxy so it can have all of that information. And that reduces the amount of data that we would have to actually initially send into the register app interface response if we had not introduced this capability. The next thing that sort of goes a little bit hand in hand in this is we created constructed payloads for our control frames. And this basically was a necessity to sort of improve our handshaking process. Before, it wasn't done very intelligently, so now with this constructed payloads, we're able to actually send structured data and accomplish things right off the bat as we're doing our handshake. So for example, down at the bottom, you can see our examples like sending dynamic MTU or max transport unit. So when an app connects to a core instance for the first time, the core can actually, again, read a configuration file or even notice maybe what transport it's on and can send a dynamic MTU to the proxy saying, this is as big of payload as you can include in these RPCs. Now, of course, this is all something that happens at the library level, and app developers don't need to worry about this, but it's a nice feature that will introduce a lot of performance gain in the end. To accomplish this goal, we actually used something called BSON, which is a binary representation of JSON. And just to be a little bit smaller in size for these payloads, that's why we went that way. And it sort of ties along with our RPC messages are structured in JSON, so it's a very familiar sort of flow and easily readable when debugging. Lastly, we wanted to make sure that these payloads, while constructed and giving the ability to include information, didn't grow. We wanted to make sure what was being included in these payloads were very specific and necessary. So we only created a flat level structure. This means that there will only be a handful of parameters in each of these payloads and these control frames. Another thing we added in this coming release are metadata tags. So before, when this was introduced, the show RPC just had these generic main field 1, 2, 3, 4 lines that apps could send their text through. Now that works in a great way of, the core doesn't have to know what type of app it's connected to. It can just display this information in the templates, regardless of if it's media or weather or news or a soccer app. It doesn't matter. It can display them all in the same way. And that's great in that terms. But next, you needed some sort of context to this information if you wanted to get an even deeper integration. So adding this optional field of metadata allows core to actually possibly put icons next to these fields, or if the system wanted to display maybe artist and song title on its cluster, but it only had a single line, it could look at, okay, the show main field 1 and 2 are actually artist and song. And now I can grab this content, put it together, and display it on these other screens in my car. Next, a feature for the video streaming apps. For navigation, we introduced basically an ability to parse through that navigation's apps, find focusable items, and send those rectangles over to core. This allows us to interact with other touch inputs beyond just touchscreens. So for example, like click wheels and touchpads. So users can select through these different items, and then the core would send back an on-touch event with the center of these rectangles. Oh, there's the actual animation. So you can see it kind of moving through, and then a user would actually press enter or click down, et cetera, and it would select that, get sent back to proxy, and it would know how to handle it. Another thing we did for video streaming was actually the introduction of a real-time transport protocol streaming. In our first iteration, we only did raw H.264, which was very simple to start with and very intuitive. Of this is just very basic video streaming, get it from the proxy to the core. The problem with that is that Core doesn't know how to handle some of those frames. It has to consume all of the data it gets because it doesn't have anything like timestamps to tell it otherwise. So with the introduction of the RTP packetization above the H.264, we actually allow Core to say, oh, I'm getting behind, I can drop some frames, and we get better performance out of it. So each of the proxies are actually going to have native level encoders in them, so we didn't have to add any actual third-party libraries or anything like that, even though like Android and iOS do not support RTP streaming out of the box. The other thing, as Timur mentioned and Doug mentioned earlier, is remote control. So we finally agreed on a solution to get into the open. And this is going to allow a lot of cool features to come. And this I consider just the baseline, but it is going to grow and it's going to become, I think, one of the most important pieces of Smart Device Link. So for this first iteration, we're only going to allow control of radio tuner and climate control. However, those are two very powerful modules within the car that are very safe to control. The first version is basically, I think, only going to be allowed for OEM apps and select preferred partners, as we don't have the concepts of zones in this version. There will only be a single module of each type. So when the app queries the system using the get system capability RPC, it's actually going to get back one radio tuner and one climate control if they're available. And those will, I believe, be designed to be the driver's radio tuner and climate control. So moving on to something that was released a little bit ago was Manticore, and Timur kind of touched on this, and he'll talk about this some more in depth. But essentially, Manticore just gives access to a dedicated instance of SDL Core through a browser. So you don't have to download the VM, you don't have to clone the repo, build it, realize that there's so many dependencies, and sort of become a semi-guru on Linux before you can actually start testing your app on something. You can just browse to this website through the Smart Device Link developer portal and start developing. So if we take a closer look, you can actually see some of the core logs going on here from when you send information, as well as doing some what like hard buttons would be, and you can do voice recognition through it, as well as vehicle data. So you will also know, yes, this is Taylor Swift, and no, I didn't take this screenshot. So what's next for Manticore? I think one of the biggest things is actually implementing all of the templates that are available in Smart Device Link, and that's one of our big goals, is trying to get all of those in there so it becomes very easy to test and use all of those different templates. Something I think that would also be very powerful in the future is being able to build different versions of Core. So right now we only have the single version that we put out to developers, but in the future I can see it becoming very easy to use some sort of drop-down list and say I want to select this release of Core and I want to test against this release. And hopefully we can maybe tie that in with some sort of knowledge of what the different OEMs are using for their baseline code for their core instance as well. So it'll be very clear if I want to test between Ford and Toyota, these are the versions that I need to test against to make sure my app still works correctly. And then the next piece that sort of comes along with that is actually introducing more of the OEM skins, because that's one of the biggest challenges. While it's a really great thing for OEMs to be able to customize their UI and use essentially these same templates and layouts, it's a headache for app developers to know how is my app going to look on all of these different OEMs' head units. So that point is not lost on us, and I think that's something that we're trying to move forward and we're trying to get as a goal for Manticore. Another piece we just released within the past couple weeks is the Shade 2.0 server. So initially, as Timur was mentioning, this Shade server is basically the application ID generation server. But it came to light that we wanted to try to keep this nimble and small in scope, but for the needs of the consortium, it sort of grew out of necessity. So instead of being the super helpful application ID database, it's the super helpful application information database, which is handy so we could keep the acronym. But it sort of now keeps all of the information about about the apps themselves, including like what permissions they actually need. So when an app wants to, let's say, access GPS and speed, they're not going to have to go to every OEM's developer portal, and say, yes, I need access to this and I need access to that over and over again. The idea is that they log into their Shade developer portal page, and they can see all these permissions that they can request and just click on them as a checkbox, and then all of a sudden that is propagated out to all of the OEM's policy servers. So the Shade database being redesigned actually became a central hub for the developer portal, the OEM's policy servers, and another server called Whopper Junior. So we reduced a lot of redundancy in all of those pieces by basically growing the scope in Shade. So we only implemented this one time instead of having to implement it a bunch of different times. The other thing that came along with the Shade 2.0 release is a new production-ready policy server. I think we've kind of touched on what policies are, but I know Timur will give you a much better explanation of what they're used for in his later presentation. But essentially, they are what Core uses to know how to grant permissions for different aspects of the infotainment unit. So the second version of this policy server actually now connects to Shade, gets all of that application information, and can generate a policy table dynamically. Before, our first example was pretty much nothing more than an FTP server for a JSON file. But we're getting to the point where this can actually be just cloned and then thrown up on AWS, and OEMs can just get started. Some of the things that are coming up next. This initial release only was basically headless. So we wanted to have to go through a process of actually introducing a UI to be able to control approving and denying apps. So there's actually an evolution proposal in right now that's getting voted on tonight that will be picking the JavaScript UI framework, in which the project maintainer had suggested Vue.js. So if you want to see that proposal, it's in right now, and you can get a few words in the next couple hours. Beyond the UI, we want to make sure that we're giving more granular permissions for OEMs beyond just approving and denying apps. So if they want to give specific permissions, if an app requests GPS and speed and the OEM says, I just want to give you speed, I don't want to give you GPS, we want to enable them to do so. We want to also take it and make it as simple as possible. So if there's some sort of script that we can write that is cloned and then automatically gets thrown up to an AWS server, or can upgrade their server, we want to do that as well. We want to make this as painless as possible for OEMs, as we know this is not something that they want to spend time on. And every OEM in the consortium is going to need this functionality. So this is sort of our example UI. Nothing is set in stone yet. This is just kind of what we were thinking. As you can see, there's this queue up here of pending requests to get access to this OEM, and this is their policy server UI, and they can approve and deny them, and they go into approved, denied application lists. They can also actually view their policy table. So if they want to see if something, they see something in the field that's not quite right, maybe they just want to go investigate what their policy server is actually creating it without having to go through the actual process of connecting an app to Core and then dumping that policy server. So upcoming goals. These are goals that aren't coming out right now, but they are near term in next year or so I think we're looking for. We obviously know that Wi-Fi transport is a big one. It's obviously on our plate. There has been a proposal entered, and we're currently working to find the best design that we can. So I think this is a good example of something that was brought up initially, and we all agreed, yes, we need this functionality, but as a consortium, we came together and said, but we need to make sure we do this right. So we've had a workshop on it. I think we're going to have probably at least one more to talk about this, but it is in the pipeline. We're also constantly working to improve our proxy APIs. And that's something I have another slide on I can talk about more. We want to introduce something like template themes, and again, take this with a grain of salt because it's kind of just where I see it going, not necessarily the SDLC as for sure. We also want to introduce a centralized sort of app certification for SDL. because we know, again, this is another burden for app developers. They don't want to have to go to all of the different OEMs for all of these different certifications. We want to at least create a baseline certification, even if it's self-certification, and then possibly even an automatic certification after that. We want to make it as easy as possible for apps to get into as many OEMs as possible, and we want to make sure that the apps that OEMs are actually certifying at the next level are up to a certain quality. So it's reducing the amount of time necessary for both the app developers and the OEMs. Secondly, we want to do some sort of infotainment certification, because that's another piece of this. Not only should the apps work to a certain standard, the infotainment systems should. So we're trying to come up with an idea of what does a baseline smart device link functionality look like, what are preferred elements that need to be included to get that sort of status. Another proposal that went through, and I didn't link it on here and I apologize, was a hardware validator app. So again, we realize that this certification process is going to be difficult for OEMs, so we're trying to create an app that will give you on-screen prompts of like what your head unit should do in these different situations, as well as sending the combinations of RPCs in the background to sort of test this infotainment to make sure it works up to our guidelines. So as far as improved proxy APIs, one of the first things that just got accepted, I believe, last week or the week before is auto-setting correlation IDs for RPCs. If you don't know what these are, then you probably haven't developed anything smart device link related for Android. Every RPC actually requires you to manually enter one now, which is kind of a burden and unnecessary. The correlation IDs themselves were very important when we began this, but now we've introduced RPC listener callbacks that you don't necessarily need to know these correlation IDs, so it's not important for the developer to manually set them and know them. So this will be handled in the background, and it is an accepted proposal that will be coming at some point. Something else we've introduced and had accepted for Android and iOS is a systems capability manager. So going back to the system capability request RPC, we realize now there might be a disjointed experience between what is included in the register app interface response and what do you need to actually request afterwards. So creating a manager that can parse through that response and know when it needs to do a request asynchronously is important for developers. So there'll be a single manager that developers can just ask, hey, I need this capability, return it to me. And we'll have clear documentation saying which capabilities can be grabbed synchronously and which ones actually need to send out an RPC, so you'll want to do this asynchronously. Another proposal that was accepted just recently was sending multiple RPCs at once. So right now, instead of just doing a bunch of for loops, waiting to just rapid fire a bunch of RPCs, we're going to allow developers to send a list of RPCs in, and we will send them out. And when it makes sense, we can listen to make sure that the first RPC sent out, we get a response from, so we can chain them together and the developer doesn't have to. Because there are certain RPCs that you cannot just rapid fire across, as well as some OEMs have limitations regarding how many RPCs you can send per second. So we will take that on in the proxy level so the developer doesn't have to know anything about that. Lastly, one of the things that we're trying to do, and we've had some workshops on it, and we're trying to come up with how this is going to look, but we want to create a more native experience when it comes to this API. Instead of developers having to know about all these different RPCs, all these correlation IDs, we want to create something that's very easy and known to developers. So something as simple as like, okay, here is your window, and you just give us your layout, and then you update your native views that we have either extended or tagged or something like that, and then we can actually gather the content from those, and then we know how to send out and which RPCs and when, so we can do that for you. I think that's a little bit further off, but I think it's important to know that we are taking that into consideration and we're trying to move forward on that. The other thing we've recently talked about, and again, this isn't for sure, but I think we're trying to enable app developers to maintain some of their branding as well, right? We did a really good job initially of letting OEMs keep their brand, but somewhere along the way, we kind of forgot, apps have branding too. So we're trying to strike a balance between the two. And something we talked about was actually adding themes to these templates. So, even setting a couple different, your main color, your primary, secondary color, something like that. Something like that would help immensely of making your app look different than another person's app. So, making Spotify look different than Pandora, bringing that experience that the user is used to from their phone onto the head unit again, kind of creating that compelling experience. So we've touched on this a little bit, the evolution process in itself. I think Team Morgan is going to go over this, in a little bit in more detail, but essentially this is the process we have now. Anyone can submit proposals, we review them in a steering committee, and then we have action items based on, the community feedback and the steering committee feedback. So recently we've noticed that we're sort of entering a stage where we need to kind of break this apart. So something we've kind of been talking about is actually separating this into a two-step process. The first process will be essentially, the pitch, getting the main idea. So for our Wi-Fi, for example, everybody in the SDLC agrees, yes, we need Wi-Fi transport, and it should go through this first process very easily. The second process is the actual implementation details of how are we actually going to accomplish this. And this is where we sort of create this feedback loop of interested core members that can constantly give feedback and make sure this implementation is getting done right. Because what we also don't want is for anyone that's making contributions to be doing this all behind closed doors, and then all of a sudden when they bring it to the open, we're like, no, that's completely wrong, and they've just wasted all of their time. So I think breaking it up into these two steps is something that we see as a good step in the right direction. And for anyone that knows the Swift evolution process where we kind of got this from, they have seen almost the identical issues as we have, and this is kind of what they're doing. This is our sort of adaptation to that. So the last thing I kind of wanted to talk about, and this is maybe crystal ball-ish, I guess, in my opinion, but I think autonomous vehicles are going to completely disrupt car connectivity technologies. So if you'll notice something about the screen or this image, what is missing? There's no screen there. So how is any sort of video projection solution going to work in a situation like that? And again, this is just very generic autonomous vehicle, and some will have screens, but there's another piece that you have to see, and that's these people are talking to each other. They're not focused, forward on the road and at some screen. So those projection technologies, I don't think are going to survive. I think what's going to survive is a technology that can provide actual content with, context, as well as some other differentiating feature. And I think that's smart device link, because we have the ability to send over content to an autonomous vehicle, and it can display it anywhere, regardless of screen size. We also have the ability to do future technologies like remote control, right? So a user can use their app in a headless autonomous vehicle to actually control their car. They can set their seat preferences. If there's nothing there, they can set their climate control from their phone using SDL, even if there's no head unit or no actual climate control buttons. So I think we're positioned in a very good spot. And that is it from me. So I will take questions, and if the question is, can you get up and go to lunch, that's going to be up to you. Looks like we have one.
One question.
Perfect, one.
My question was actually, you mentioned Wi-Fi transport.
Yes.
Without saying what it is. What is Wi-Fi transport?
What is Wi-Fi transport?
That is enabling the smart device link technology over a Wi-Fi transport. So we're looking into which Wi-Fi technology to actually use, right? And I think maybe that's your question. It's like, are we talking about like Wi-Fi direct, or are we talking about being able to connect to a car's hotspot, et cetera? And that's something we're getting through right now. Like that's what we're discussing. Is like what's the best technology to use? Because at first Wi-Fi direct seems like a good idea, but then you look at iOS and you're like, oh, I can't really do Wi-Fi direct over iOS. So we're trying to find the best solution that's going to work for a user. Because without let's say like a modem in the car, if your phone connects to your car's Wi-Fi, and then all of a sudden it doesn't have internet through that Wi-Fi, you have to maintain those two connections. So it's something we're working on and making sure that we're doing it right. And that's what I'm talking about as far as like, we want to make sure we get it right.
Very good. Perfect lead into lunch.